This is the 25th lecture, 25th lecture on FET differential amplifiers, and we shall also introduce today power amplifiers, that is large signal amplifiers. The circuit for an FET we already drew. We shall draw a part of it today to start the discussion, and this part is the initial part Q1 and Q2. This voltage is VG1 and this voltage is VG2. The two sources are connected together, S1 and S2, and they are connected to a resistance R sigma. This current is ISS and this is minus VSS. The rest of the circuit is two RDs, I could as well draw them, R sub D, and these connect to plus VDD. I have not shown the source part. Let the two gate voltages be VG1 and VG2. Then the differential voltage applied at the input V sub D is equal to VG1 minus VG2. It is the difference voltage applied between these two terminals, and as usual with the BJT amplifiers, as we did with the BJT amplifiers, in the FET also we find this difference VG1 and VG2 as V, I beg your pardon, this will be simply VGS1 minus VGS2. Is that okay?
This R sigma sigma.
Okay. Okay, all right. V sigma sigma, and if you want
R sigma sigma.
okay, R sigma,
I sigma sigma.
because two emitters are connected together. So instead of one subscript we use two. Hardly matters, but okay, I agree. Do you see that VG1 minus VG2 is simply equal to VGS1 minus VGS2? Okay, is that point okay?
Okay, sir.
Right. Now we are in business. Our purpose now shall be to express VGS in terms of I sub D, because we want to calculate these two currents, I sub D1 and I sub D2. Obviously, one of the relations is that I sub D1 plus I sub D2 would be equal to ISS. There are no gate currents at all, and therefore this is a exact relationship.
So
No,
please tell again why VG2 is VGS1 minus VGS2.
oh, VG1 minus VG2, because this point is common. So it is VGS1 minus VGS2. Okay, this is VGS1 plus minus,
VD is equal to.
and this is VGS2 plus minus. Okay, so it is the difference between the two. If I write KVL, VG1 would be equal to VGS1 minus VGS2 plus VG2, and therefore VG1 minus VG2 is equal to the difference between these two voltages. And we obviously see that ID1 plus ID2, the two drain currents, add up to ISS. Okay, there is no gate current, and therefore no assumption on beta or GM is necessary, as was necessary in the case of BJT differential amplifier. Now you also know the current voltage relationship of an FET. It is ID equal to IDSS 1 minus VGS divided by VP whole squared, provided VDS is greater than VGS minus VP. And we assume that this is true. VP is obviously the pinch of voltage. And you see that ID equals to IDSS if VGS equal to 0. Okay, that is, if you recall the characteristics, VGS equal to 0, the value of the current is IDSS. Okay, from this relationship we can find out VGS as equal to VP multiplied by, yes, 1. I don't want to do these algebraic steps. Yes? 1 minus ID by IDSS. No. Which one is square root?
ID by IDS.
Okay, that's fine. And therefore, if I substitute in the relationship for VD, which is VGS1 minus VGS2, what I will get is VP, I am avoiding these algebraic steps, multiplied by square root of ID2 minus square root of ID1, okay, the whole thing divided by square root of IDSS. Is this relation okay? Is it obvious? All right. Let me repeat this. V sub D equal to VP. Let me write it in a more clear fashion. Multiplied by square root of ID2 minus square root of ID1.
This is an expression for VD. So VD.
VD. Right. This is an expression for the input differential voltage. Okay. And the other relation is ID1 plus ID2 is equal to ISS. These are the two relationships which, when simultaneously solved, will give you expressions for ID1 and ID2. Okay. This is our aim, to find out expressions for ID1 and ID2 in terms of VD, VP and IDSS. And this algebra, again I leave it to you, the values are ID1 and 2 is equal to ISS by 2, 1 plus minus. It is not as simple as in the BJT case, it is somewhat involved. VD by VP, distinguish between D and P, then twice IDSS divided by ISS minus VD by VP squared. Why does the square come? Because we have squared this. Okay. VD by VP squared multiplied by IDSS divided by ISS squared, curly bracket closed, to the power half, and then this bracket closes. This is the expression. I urge you to clear out this algebra and obtain this. Even though it is a horrible looking expression, it turns out that if you plot ID1 and ID2 versus what is the variable VD by VP, then the plots are exactly similar to the plots for IC1 and IC2 versus VD by VT in the case of a BJT. In other words, one current increases, the other decreases. The plots are exactly similar. What you plot is VD by VP, and you plot here ID1 and ID2. It turns out that these currents are very similar. I should not have drawn the, well, okay, this is 0. This is 0 for the current and 0 for the voltage. I should have brought it here, VD by VP. Okay. And the two currents flow like this, and the other one is like this. Exactly similar. One rises, the other falls. This is ID, and at VD by VP equal to 0, as you can see from this expression, it is exactly ISS by 2. Okay. So, this current is ISS divided by 2. The maximum is obviously ISS, and we assume you may or you may not ISS as IDSS, then this current is exactly ISS. Okay, otherwise it will be modified by IDSS, but that is not important. What is important is that the plots are very similar, okay, and therefore all that is said about BJT differential amplifier also applies here. In other words, if I find out VO1, no, what did we say? VOD. No, first we have to find out VO1 and 2. This would be VDD minus I sub D 1 2 times RD. Okay, I was waiting for that. So my VOD is equal to VO1 minus VO2, which would be ID2 minus ID1 times RD. And it turns out that a plot of let me give you the expression by clearing the algebra. This becomes equal to minus ISS RD VD divided by VP, then within curly bracket twice IDSS divided by ISS minus VD by VP squared times IDSS divided by ISS whole squared, curly bracket close, to the power half. This is also a quite involved expression, and it is a quadratic expression.
So where is this bracket? Yeah, where is the bracket after 2 ending?
Oh, here. Thank you. This comes from the expression for VGS minus VGS1 minus VGS2. It comes from the same expression is repeated here. Okay. Now this is not a linear expression. That is, VOD does not vary linearly with VD. Okay, with VD by VP because of this square expression here. It is actually a cubic. However, near VD by VP equal to 0, near VD by VP equal to 0, the expression is approximately linear. Exactly the same way as in a BJT. Okay, and if you plot VOD versus VD by VP, it turns out that the situation is somewhat like this. It's very nearly linear, and this voltage, can you guess what this voltage would be? No? Pardon me? ISS times RD. And this voltage is, in the BJT case, it was IEE times RC, and the other one was minus ISS times RD. And these limits of linearity, it's approximately linear when VD by VP lies between minus 0.5 and plus 0.5. Okay? So these are the limits of linearity of an FET amplifier. And yes, any question? Okay. Therefore, we can find out the gain. Now, how do we find the gain? A sub D would be, by definition, VOD D divided by dVd, and since this expression, since this curve is approximately linear, we evaluate at Vd equal to 0. Okay, and if you do that, let's take the expression. Our expression is formidable looking expression, VOD minus ISS RD VD divided by VP, then twice IDSS divided by ISS minus VD by VP whole squared IDSS divided by ISS whole squared. I am repeating the same expression. If I differentiate this and put VD equal to 0, if I differentiate this and put VD equal to 0, obviously I don't have to differentiate this expression. Isn't that right? You see, it is VD multiplied by an expression containing VD. So it's a product of two functions. Differential coefficient of this, which would be 1, multiplied by this at VD equal to 0. Alright, so we will be left with only this term. No under root. It's under root, okay. That under root comes. The second term, we will have VD here, and since we are putting VD equal to 0, we don't have to differentiate. These are tricks of the trade. And you have to look at the expression and do. And I can write this by inspection. That is A sub D, which is minus D VOD divided by D VD, would be simply equal to minus I, pardon me?
Why should there be a minus sign
before the differential.
for the differential?
Why not?
This was coined by input signal derived from